All right, everybody. Welcome back to another episode of Pal Fabrication. Hope you guys got some useful information out of the first video. In today's video, I want to address, was my 2kW FiberSabre FiberSabre purchase actually worth it? The quick answer is yes, 100%. We've had super success with it. A little bit of learning curve, got over it, fixed it, got on to the next phase of it, whatever you want to call it. In the first part of it here, I'm gonna try to follow my notes decent today so I don't have my that Greg was complaining about when he edited the last video. First question was why FiberSabre over other brands? We chose FiberSabre, gosh dang it, over other brands. One, because of the price, and two, strictly just because we had used them before. Like I said in other videos, we bought our plasma from them. They were super great to work with on that, super great technical support. Thought, hey, they were good the first time, they're gonna be good the second time. Why not go with them again? The other question is, why 2kW instead of 3K or 6K? So FiberSabre specifically offers a 2K and a 6K. Went with the 2kW because of the single phase power. This thing is a 220 volt single phase power. It runs on a 70 amp circuit. So the line we ran from our breaker panel over to the 100 amp panel that's here beside the machine, we ran a 70 amp line over there. Wasn't anything super crazy. Our Hypertherm 85 actually ran on a 60 amp circuit, so it wasn't that much of a power difference, and the actual amp draw was less than the plasma. Obviously, we didn't know that when we bought it, but after getting it in, running some tests, doing all that. If you haven't watched the laser versus plasma video, I go over a lot of that content, if you will, those questions in that video. Why did we go with a 5x10 bed? When I bought my 4x8 plasma table, it was in the price range of what I needed, what I wanted, if you will, what I could afford per month, because I dang sure didn't have any money then. Not like I have any money now, but I dang sure didn't have any then. My wife, whenever I bought it, was, hey, just go ahead and buy the bigger one. We'll make it work. We'll figure it out. And I didn't want to. The price point scared me. The monthly payment scared me. Didn't really think that I would even be using a big table. 5-6 months down the road after owning it, hey, we needed a bigger table. So for this one, I don't remember the exacts. You have to get a hold of FiberSabre and get with them on pricing. I think the difference between the 4x8 and the 5x10 2kW machine was somewhere in the $10,000 to $15,000 range. So when you're spending $75,000 to $90,000 as it is anyways, there's no sense in skimping. If it's a big job to get the machine in, it's a big job to get it wired up, to get it up and running. It's just a job in general. So if you're gonna spend $75,000, and like us, luckily we had a friend of ours that helped finance this thing. We didn't have to go to a bank or worry about a bank. But if you're going to the bank, there's no sense in saying, oh, hey, this will get us by for 6 months and then we're gonna have to buy the bigger one later. You still got to pay the first one off. So in my opinion, buy the big one, buy your first one, buy your second machine first, I think is what FiberSabre says. Buy once, cry once. On this machine specifically, I feel like it's a small manufacturing machine, if you will. So FiberSabre markets it at 3/8 and down on production. We run 1/2 inch. I wouldn't say on production really. The longest files we run on 1/2 inch is probably 3 hours or so. And typically we're not doing those back to back to back. We do 1 or 2 plates and then we're done. It's a good starter machine for small manufacturing. Got it wrote here, light production, what it's made for, if you will. Another reason why I didn't want to go with the 6kW right off the bat specifically was the size of the plate. So I talked in other videos, friend of mine, Gavin, talked to him. I was like, man, do I go ahead and go with this big machine that'll cut up to 15/16? No. After, talking with Greg and the shop talks, between me and other business owners, how much big plate do we really want to be messing with? Big plate's hard to store. It's, massive as far as trying to deal with it. The forklift, only lifts so much. The jib crane that I'm going to put in here is only going to lift so much. There's no sense in just tapping out the max on everything with everything we do. And 1/2 inch plate, don't get me wrong, when it falls and hits your foot, it hurts. But 1 inch plate, when it falls and hits your foot, that's probably the difference between, it bouncing off of your steel toe, depending on the size, obviously, and cutting your toe off. So I didn't really want to be messing with that. If I bought a 6kW FiberSabre, then I was gonna have to buy a bigger press brake, and we knew press brake was right down the road. It just didn't make much sense to us. Being a two-man shop, if we had a huge, wide open, big manufacturing facility that everything was on a suction cup or on a forklift everywhere that it went throughout the shop, or we had clamps and stuff to load it into a press brake and all that, hey, maybe at that point I would have messed with it, but still, we're doing okay right now with the mining operation and cutting everything that we need to. And don't get me wrong, there is some products that those guys want that are bigger. It just doesn't make sense for us where we're at. And again, going back to the power issue, the 6 kW was a 3-phase machine. I didn't really want to be messing with the driver to put it in. I didn't want to be messing, it was like $60,000, as I mentioned, to bring power in from down the road. It just didn't make a lot of sense to me to be screwing with a 3-phase machine when single phase is what we had. Let's make the most of it. Well, like I said, we're doing just fine with this machine for 1/2 inch and down. To be real honest, the 1/2 inch plates are kind of a pain in the butt. I don't really want to be messing with anything else any bigger than that or much bigger than that. So it will cut. They're marketing it at cutting 5/8 and down, 3/8 on production. Like I said, we've run 1/2 inch on ours. It runs just fine. The only thing I will say on 1/2 inch, because we've been cutting AR plate, not just regular 1/2 inch plate, I don't know if it's the density of the plate or what, but we have to run it a lot slower than even 3/8 is. I mean, there's a huge step in travel speed from 3/8 down to 1/2 inch. So obviously you have a lot of gas consumption there. In future videos, I want to dive into using compressed air. It may be a lot slower, but what's the comparison between kilowatts that the air compressor is running or just buying and replacing oxygen bottles? You know, I want to really be able to jump into that. 5x10 bed size. Here in a minute, I'll get up and pull the bed out. If you didn't get to watch the review video, we're going to kind of go through a little walkthrough today. The controller system is Ray Tools. I really like that software. It's on demand. You can draw squares, circles, stars. It's got a flange pre-built tool, I think is what it is in there, that you can put all your measurements into, the bolt sizes, the inside hole, the outside hole. It's a really sexy design. There's a little bit of a learning curve with it, but it's really cool. The rough footprint, and we can get a tape measure on it, is roughly 12 feet by roughly 20 feet-ish is what this is, the footprint of this machine, but we'll get a tape measure on it. The cut quality, cut performance, like I said, it will do 1/2 inch and down. It'll also do stainless, aluminum, carbon steel, AR plate. We've been doing a bunch of AR. There's a lot of people scared of the AR whenever we first got into that world. Oh my gosh, watch out for this. Oh my gosh, watch out for that. To be real honest, it went pretty good. The 1/4 inch settings and 3/8 settings really aren't that far off from where we are on regular 3/8 or regular quarter A36 plate. Like I said, the stainless side of it, I haven't got into it enough. I don't really want to put a lot of time and effort into it because doing carbon mainly on this bed, I don't want that cross contamination, whether it's restaurant quality or whatever. So we probably won't get into much stainless on this channel. I wouldn't mind getting into some aluminum, you know, with the race cars and stuff like that. I would really like to try out some aluminum, figure out how that works, the warpage and all that, because aluminum is a whole different animal. Primarily, where this machine really sings a good song, if you will, is 3/8, 3/8 and down. Like I said, the 1/2 inch just uses a bunch of gas. The 3/8, it cuts a really good quality. We have noticed going from different suppliers material. So we had one company that came in and had a real light mill scale finish, a temper pass is what it is. And it cut different than the pickled and oiled stuff that we bought. We assumed or kind of chalked it up to being the reflection of the beam off of the plate, especially on startup. We don't know if that's 100% of the problem, but where we had 90% of our problems was on our piers. So that's something that we plan on diving into in this series. Was it an actual thing? Was it just the temperature outside that day? You know, that's another talking point there. We did have a little bit of a change in cut quality with the temperature change, whether it was the gas pressure, gas coming in cooler, or whether it was the plate being cooler and you're heating it up. I don't know what the exact reason was there, but we did have to turn the machine down just a skosh whenever when we were running from really hot plate, you know, 80-degree days down to, I think the coldest day that we've cut, it was in the teens that day. So obviously we heated the shop up, but the metal and material and everything hadn't had enough time to go ahead and raise its temperature as well. So that's something to keep into consideration if you're having trouble between hot and cold climates. Setup of this machine was super easy. We'll go into a little bit of that today. The hardest part about this machine was getting it off the truck and into the shop. So we have a big 10-foot wide by 12-foot tall door. So we had plenty of room to get it in long ways, obviously, but we still had to get it on rollers, get it back into this shop. And that was kind of a pain in the butt. To offload this machine, we used a JLG, I don't remember the exact size of the machine, but 8,000 pound lift with fork extensions on it. It was a must for that. I think that from bed to bed, it is roughly 6.5 feet-ish. So you need at least 6.5 feet of forks to do it. What we done, we had some real heavy duty channel that we used for fork extensions, had a 10-foot piece, and it worked great. It bowed the channel, don't get me wrong, but we were literally just picking it off, bringing it right over, maybe 20 feet over to the concrete slab. It was perfect. Would be even better if you had a big door that you could back a semi in, but very, very, very easy. It was 3 lines to hook up your gas, and then we were off to the races. We had the machine fired up. We had some little things, you know, like these wings for the bed to slide out on. Those things had to be installed, level the bed up, you know, the normal stuff, if you will, hook up the chiller, all that. But it wasn't bad at all. And ShopSabre's machine specifically comes with a plug-in that all of your lines just needed a plug-in. You didn't have to hardwire in anything. I hardwired all my stuff. I didn't want somebody back there changing out a bottle halfway through a file and hitting a plug-in and knocking it out of the wall if it wasn't in. On big machines like this, I just like the hardwired stuff. The software usage, like I said, Ray Tools, as far as the use of it was pretty easy. There's a few minor things we had to get into. So all of our tip sizes weren't in this machine when we bought it, and obviously it doesn't come with every tip size either. So you have to calibrate the tip so that it knows what the gas flow is supposed to be. It regulates that off of a voltage in the back of the machine. So we can go through that at a later date, but just some of the stuff to take into consideration. The gas consumption, as far as higher, lower than what I kind of thought. I talked to some other shops before we got our machine in, and they were telling us about 1.5 bottles a full day consumption. Honestly, it hasn't been that high for us. We've been cutting primarily 1/4 inch or 1/8 inch, and we can get through, like I said, they were telling me 1.5 bottles, and that was on 250 bottles. I run 300s. So on a 300, I can get through over a full day of cutting on 1/4 inch plate with one 300 bottle. So I don't know, maybe it kind of actually equals out to what they were saying. So gas consumption per day though, for us, you know, I think it's $36 or $38 to fill a 300 where we do our gas exchange at. Obviously, if you're using some of the big companies like Wellsco, or they actually just got bought out, Nexair, Airgas, those places, they're quite a bit higher on all of their gas. Personally, I can't stand those places. They've screwed me a lot in the past. Nexair actually just bought Wellsco out, and that's for a whole nother video, but they just bought the company out within the last like 1.5 years, and then immediately they go through, jack their rates through the roof, and then give me some bogus like service charge fee. So we'll get into that in a whole nother video, but find a small shop if you can, if your usage is good and they can keep up with it, that is, because I think you'll be way happier in supporting the small guy instead of the big crooks is a lot better deal. So I may get a lot of kickback on that one, but that's just my personal deal there. Next thing was noise level. So the plasma obviously was really noisy. I think that decimal wise, it was somewhere around 98 to 100. I think I've seen maybe as high as 105 on decimal with the plasma. If you had it tucked back in a room like this and can go back out into the regular shop, it may not be as bad, but it was noisy. You had the air compressor running right beside it. You had the plasma, you know, on and off. It was just a really noisy system, really nasty system too, with the water bed on it. This thing's still nasty. I mean, you can see as we walk around here in a minute, my ventilation may not be as good as I need. I'm gonna try to fix that with a bigger line here pretty quick, actually. The noise of it, I mean, it's next to nothing. When the welding shop is running, not even grinders, just somebody out there welding, the MIG weld, you can't hear this machine running. The only how I know that if it's still running is when a plate drops. So if I know if I'm hearing plate drops, every 30 seconds or so, okay, yeah, the machine's still running. We're still good to go. But like if I run up to the office or I run inside to grab something to eat, whatever, real quick, I can't hear it. I have a baby monitor that I keep on it right now, just in case I'm up in the office trying to do paperwork or whatever. I know that the machine is still running. So the quiet part of it is super, super nice. You can run it, go out into the shop, have a conversation. You can stand right here beside it and have a conversation. The loudest part about it is when the metal drops the, 16, 18 inches down into that bed. So that was a huge, huge thing. The notes I put on here was pierce speed. Something to take into consideration when we first started bidding jobs with the laser, we were going on Fusion, our software, and we were taking our loop length and then just obviously multiplying that on our travel speed. And then that was our cost, if you will. That's not legit. So what we have figured out, especially on your thicker materials, not so much on your thinner stuff like 1/8 inch and down, but on 1/4 inch and up, typically whatever your cut time is, it's almost double that between piercing and cutting. We want a nice clean pierce, go all the way through so that whenever that lead line comes over and starts cutting, it's already got all of its mumbo jumbo crap done and fixed. It's ready to go, which when I say it's crap, it's very, very minuscule. For the most part, that's a huge thing to be taken into consideration. Don't be bidding jobs for an hour because the machine says so or the deal says so on Fusion. Actually calculate it. And that's something else we can get into here in a minute. It actually has a whole job generation on there. So it'll tell you, if you've got a job, let's say it's 50 parts, 60 parts, whatever, it'll go through there, it'll nest it for you. So that's a big thing that I do like about it. Fusion and all those other softwares, they want to charge you for the nesting software. This is built into RayTools. So you can go through there, you can upload all of your parts, you can do your nest file, and then press generate report. And it will tell you the cut time, the pierce time, the total time, the material needed as far as quantity of sheets. And obviously that's dictated on how you nest it, whether you nest it 4x8 or 5x10 sheets. And then it'll give you, if I'm not mistaken, it'll give you a gas consumption, pretty close. So, and it's really, really close on there. Typically what we find is to tack on about 30 more minutes, especially with the AR plate for how dense it is. Every once in a while we'll get in a hard spot on the plate. It won't want to go ahead and pierce. But typically on all of your A36 plate, you can go off of that within about 5 or 10 minutes of what that generate report says. There really hasn't been that many software quirks, but there's a couple little things, either finding it, like the edge detect, it'll go in there every once in a while when it updates and it'll change the way that edge detects. For the first little bit, I didn't know how to get back to that. So learning it is a little different. The biggest complaint that I would have on laser cutting is getting the cut fine-tuned. So when you start messing with your focuses, where the power is as far as the plate, is it below the plate? Is it above the plate? Is it in the center of the plate? That the focus adjusts your cut quality a bunch. So between cut quality, gas, and travel speed, those are your three main things as far as cutting goes. Once you have your pierce good, those are your three main things. And they all go hand in hand. So you may be able to speed it up a little bit until a certain point where your cut gets a little wonky. And then you may have to, increase gas pressure a little bit, or vice versa. You may have to slow it down and then decrease gas pressure, but they all kind of go hand in hand. Once you do it long enough, screw up enough times, you kind of get a gist on how to fix it. What we got to doing is we got a little table here. I don't know if you can see it or not, but we got a table and we started doing, whether it was 1-inch pucks or 1-inch circle pucks or 1-inch square pucks, whatever. We put a piece of paper down and we put each cut on it and what the cut parameters were, and then went through, because eventually you're going to be so far from where you started, you don't really remember what you've done beforehand. Maybe you get lucky and enter in some good parameters, from a buddy or another shop or whatever, and you don't have that learning curve with it, but it's still super important to do that work up front so that you're not screwing around with having to grind stuff. 3/8 and down for certain. As long as you do your due diligence up front, you do not have to touch the part when it comes off the table. You're gonna have some time and gas usage, you're gonna have some material usage at the front end, but once you get that sucker set, I mean, it's off to the races. It's press go and let that thing do its work. We've found that 95% of our parts that come off of this table go right off the table, right into production. So that learning curve at the beginning is very, very crucial. Just like the stainless last week, I still had to screw around, figure out pierces, figure out cuts. You know, it's still a learning curve, but it's not near as bad. Obviously, once you get it all figured out, it takes a while. I think we had 4 days, possibly 5 days in total. You know, we started with some 14 gauge, went to 8, went to 3/16, went to quarter, went to 3/8. We messed with some half, and then we thought, oh, we're good. And then the AR stuff started coming about, and it was like, shit. Now we have to completely relearn how to do this stuff. And luckily it wasn't too bad. You know, we have AR settings now, we have A36 settings now, and it wasn't terrible, but it still was, you know, a decent learning curve there. The maintenance on it hasn't been real bad. The biggest thing for us, because we're cutting out punch plates for mining operations, is all of the drops fill up the bed really, really quick. It's not a huge problem. That's what you're gonna have. That's what I would rather be cleaning out the bed than not cleaning it out, which that means we're busy. So that's the only big thing upkeep wise that we've found so far. We're about to have to get into the first chiller water change. We're about to have to get into the first greasing and that kind of maintenance. So I can't attest for that 100% yet, but we're about to that timeline. I was gonna try to do everything every 3 months. So we're getting right there at the end of it. We haven't actually ran it a solid 3 months, but I would rather go ahead, get the chiller water changed out like they said, go ahead and do our maintenance on our machine, just because the better maintenance you do, the longer that it's gonna work for you. And the biggest thing that I found so far, like I touched on earlier, was the nitrogen consumption. So I cut out, I can't remember the exact loop length, if you will, the exact inches I cut out, but I cut out a 4x8 sheet and I probably used up 70% of the sheet, but they were big parts. So just in that alone, I mean, we're gonna have right at $200 in gas just on a 4x8 sheet of stainless, which is astronomical. Again, don't take those numbers to heart. I don't think we had everything completely set right on the machine. I went off the cut parameters in the book. It got it to cut. And then I started lowering my gas from there. I started messing with my focus, messing with my travel speed. I got it decent enough to where it was gonna cut, where it was dropping out, where I wasn't having to mess with it. That's where I stopped, just because the gas the usage was so high. Again, what do I think this machine is for? I think it's for shops just like us, light manufacturing, if you will. That 1/2 inch and down. If you don't do a bunch of 1/2 inch, I think it's really good for you. If you're doing 1/2 inch, let's say 25% of the time, I say it'd be a really good machine for you, whether it's FiberSabre or 2KW in general. I think it's a really good machine. If you're doing 3/8 and down primarily only, that's all you want to mess with, 110%. This machine is for you. The small shops, especially like us with only 2 guys, you could take this machine, put it into production, have it cut out an entire plate of 1/4 inch feet, and honest to God, never have to screw with the machine. It'll do its cutting. It comes off super clean. It's ready to go right off the table. You do not have to do any secondary cleanup, no post-process, nothing. So like our caps that we weld on, whether it's 1x2 rec tube or pipe caps, whatever, literally right off the table, right into production. Quick story on that. So we do bunk beds for Camp War Eagle, as I may have mentioned in podcast or something before. And typically on our caps, we would be cutting out inch and a half, so they'd actually be 1 3/8 caps on the plasma. Every cap had to be ground, every cap had to be wire wheeled, every cap had to be screwed with coming off. And even after you ground it, even after you cleaned it up, pretty much every cap at least had some form of porosity in it. Whether it was on a long weld and it just popped, whether it was on a startup and it popped, whatever, they all had porosity. So this year, or last year rather, when we built the beds, we cut out 480 1-inch caps. There's 1.5 inches of weld all the way around. So you do your figuring on inches per minute there, or inches of welding. Out of 480 caps, he had 1, maybe 2, I think it was only 1 cap pop porosity. So it's a huge, huge, huge upgrade. On the plasma with the caps alone, we were taking like somewhere around 2 hours, I think, to cut out those caps. This took an hour to cut out all the caps. So we had 2 hours on the plasma cutting them. We had another 2 hours of cleaning up, screwing with all those little bitty caps, trying to get them cleaned up and ready for production. This thing, an hour, they all fall on the bottom. You pick them up, or we found the micro joint thing, which is a really cool thing with the laser. Micro joint, twist them off there, boom, right into production. You did not have to screw with any of it. So that is a super, super, super big thing for small shops. Time is money. Yes, the machine is expensive, but it's a huge help when you don't have to sit there and dick around and screw around with parts, cleaning them up, moving them over, finding them out of the water, or even a downdraft table of a plasma, finding them in the bottom of the table, trying to sort through all that crap. That's a huge, huge, huge benefit, or was for us. May not be justifiable for what you're doing, but it dang sure was for us. This machine specifically, the 2KW, if you're doing heavy duty stuff, 1/2 inch and up, this machine obviously is not for you. Laser world in general, you know, I don't know. I've been around some of the bigger ones, and you know, you see all the videos, those guys cutting, you know, 2 inches with the laser and all that. That's grand and great, but I don't know. Unless the speed is just there, that may not be the best thing for you. I've mentioned on the price range a few different times. This machine alone and the wiring to get it over ended up costing us somewhere around 90 grand. I don't have the exact number, but it was between, and we done the wiring ourselves. That's a big thing to take into consideration there. So between getting the machine off the truck, wiring the machine and doing everything. So let's, hypothetical numbers, because I don't remember exact. Let's say that this machine's 85,000 whenever I bought it. If you have a licensed electrician come in and do your wiring and stuff, we hard piped all of this stuff. So we had a decent amount in just materials. But if you have an electrician come in and do it, you're probably gonna have 5 to 8 grand in just electric. So let's say 5 grand to keep numbers easy. You're gonna have 90 grand in electric and the machine. And then, you know, say you don't have a friend with a 8,000 pound lift machine, you're gonna have to rent one of those. Our quote actually just to get our press brake off was 2 grand. So you're gonna have another 2 grand in rigging company just to get it off the truck and set it in the shop. And then that's hoping that you can get the machine the rest of the way by yourself. So you're probably gonna end up having somewhere around 3 grand in it. So the total price on it, you know, by the time you buy bottles, by the time you, that's another thing, bottles were somewhere around $550 or $600 a piece. You can rent bottles. I like to own my stuff. I don't know why, it's just the way that I am. Crunch the numbers on it though, really, I don't know that owning your oxygen bottles are really that big of a difference. The company that we use, Rogers Welding Supply in town, you know, they're really good to us. We rent some and own some. So they'll fill our own bottles and they'll obviously exchange our rent bottles, no problem. I think, you know, Terry and I up at Rogers Welding Supply were just talking about this yesterday. I think if you rent bottles, it's somewhere around a 4 to 5 year mark before they actually pay for themselves. So if you're a small shop like us and you're kind of already tapping yourself out on buying the machine, just go rent some bottles. If you want to go buy bottles, I think our bottles, I bought 3 of them, or I bought 6 of them rather. And I think I ended up right at $2,000 with shipping and all. So that's kind of expensive. You know, I can rent bottles for quite a while at that rate. But let's just use the broad number of 100,000 because that'll get you really, really close on buying one, getting it in, getting it dropped, getting it wired up. You know, that'll get you in the ballpark. You know, if 100,000 scares you and you're like, oh, I need it down to a penny, don't go buy the machine. Don't stretch yourself that thin. I've done it a dozen times in business. Don't do it. But the ROI discussion, I'll just pull out the calculator here because I'm no mathematician, whatever anymore. So on a $100,000 machine, our rate on our machine is 180 an hour. I'm not saying that that's the industry standard. We've actually been told we're a little low for the industry in the laser cutting world. I'll get into a whole nother video of the price breakdown, why I am where I am and all of that. I didn't feel it was right. It's no different than a journeyman welder coming in and making the same money that an apprentice is. It just doesn't really set well with me. We're new into the laser world. We don't have a lot of work. We're not coming into cutthroat, but we're coming in to learn. We can come into the market a little cheaper than everybody else and be able to learn at that rate. So say it takes us an hour longer, maybe 2 hours longer. It's still about the same rate as what you would have with a regular shop. But at a $100,000 investment on this machine, at 180 an hour, that's 555 hours is what it would take. In a working year, there are 2,080 hours in a working year. So let's just say you run this thing, half of the time, you're gonna be able to ROI on this machine very quick. If you can get the work, get the things rolling in, and there's a big argument there as far as just the machine ROIing. Yes, the machine can ROI, let's say 600 hours, because you're not gonna be able to keep everything that you make. You have gas consumption, lenses, you have nozzles, you have all that stuff to take into consideration. So that 600 to 650 hours is probably where you're gonna be at. We'll break down all that stuff in another video. But I think, you get a laser in, the production wise that you'll see on it and the lack of post-process it'll blow your mind. And, say there's 600 hours of cutting on this a year. And with the plasma, that's 600 hours of having to clean up. Now, again, I'm not bashing the plasma. The plasma is what put us on the map. That's what we had the money for at the time. That's what we went with. If you were a small shop like we were, 5 years ago, and that's all you can afford, buy it and start somewhere. Start stocking back some money off of that plasma to buy a laser down the road. It doesn't have to be right away. That's all the numbers that I've got for today on this video. I'll do a quick little walk around here, show you some of the stuff real quick. I'm not gonna get super in depth, but I don't wanna leave you hanging on some of that stuff. All right, do a little Vanna White here. Here's the machine, 5x10 pull-out bed, like I mentioned in the video, really nice. The only quirk that I don't like about it right now is obviously you can't reach all the way over. If you're cutting out small parts, say you didn't put a micro joint in or whatever, you gotta reach over, gotta jump up on the bed to do your cutting. When we get done with a sheet, obviously we cut it up. This sheet was, okay, this is the biggest remnants that's left. Let's go ahead and leave it. But, oh shoot, I had a part right there. I've got to get up here, I got to cut it, I got to grab the part, whatever. Very, very minor. Coming around to the back of the machine here, Jebediah. So we got the chiller turned off at the moment just because it was really noisy for the video. But this is the chiller. We've had this thing running on 3/8 plate for as long as about 10 hours actually is our longest cut time on it. And it's done excellent. Haven't had any overheating problems. We have this cabinet off right now specifically because our USB port that goes to the front of the machine ended up crapping out on us. So I had to put the mouse and keyboard little pendant deal USB back here, and it didn't want to communicate with the door on, so I just left it off for the time being until we get a new one of those. Just a real light review. So we've got oxygen bottles that we use. We just use a regular oxygen regulator. We've got ours set on 50 pounds. So it does great for us. I think our highest PSI right now is somewhere like 12 to 15, I think. But nevertheless, it's super easy. These are the 3 lines that you need to hook up. We have a 4th one down here for our vent fan. That is fume extraction. That's something to take into consideration as far as price. It's got to be a pretty good size fan. Where I was telling you before in the video, I screwed up is I ran 12-inch up and over, and then over here, Jebediah, get around to it. Yeah, I necked it down to 8-inch to go ahead and run it out. I thought it would be fine. I thought it would flow enough. That is not correct. So I don't know my volumes, my velocities, and all that stuff. So I'm going to go ahead and run 12-inch all the way out the wall, and then we'll see how it works. But nevertheless, this is the back of the machine. Super easy, super nice. We'll go ahead and push this bed in, show you the pull-out table real fast. I'm not going to pull out that front one because it's full and it's going to be really heavy. So this one's already really heavy. Nice pull-out drawer. Obviously, you can see we've already got it piled up with punch plate material. I like this design as far as clean out and all that. I do think later on down the road, if I could, I would build some sort of fork tray for underneath of it so I can come up with the forklift and pick these heavy freaking trays up. Because right now, it's a good old square tip shovel, picking it up, putting it into our short iron bin. Hopefully you guys get some good information out of this. Thanks for tagging along, and I'm having fun with these videos. So we'll see you on the next one.